sauto works best with formalizations which use inductive types a lot. Formalizations where predicates are defined with inductive types. However, it is possible, only sometimes a bit less effective, to use sauto with predicates defined as computable Boolean functions. The reflect module declares isTrue as a coercion and defines some tactics related to Boolean reflection. It is not strictly necessary to import the reflect module for sauto to handle Boolean reflection, but we will also use some other tactics from this module. We repeat our inductive definition of a sortedness predicate, and we define a computable Boolean function sorted B, which evaluates to true if and only if its argument is a sorted list. We show that these two definitions are equivalent. Induction on L followed by sauto suffices. Setting bref to on enables what we call here Boolean reflection, a conversion of Boolean statements, that is arguments to the isTrue coercion into corresponding propositions in prop. Here this sorted B is really an argument to isTrue, which we don't see because the reflect module declared isTrue as an implicit coercion. I will now go back and select display coercions in CoqIDE's menu so we can better see what's happening. Now we see that there really is a coercion isTrue here, which converts a Boolean into a proposition. Okay, now let's go a bit more step by step through a proof of one implication in this lemma. We show that sorted BL implies sorted L. We start with induction on L. The base case is trivial. For the inductive step, let's try sauto. We see it doesn't quite work. It takes too long. It cannot find the proof in reasonable time. Let's try doing a bit of this proof manually. So let's use simple first. We see that simple reduced this sorted B and exposed a match expression here. Now the tactic case split from the tactics module eliminates one discriminant of a match expression occurring somewhere in the goal or in some hypothesis. Here it will distract L, which is matched on in the goal. S-trivial is one of the weakest and also the fastest solvers available in the tactics module. It is essentially the solver sauto uses at the leaves of the proof search tree. S-trivial solves simple goals and fails quickly on more difficult ones. So here we distract L with the case split tactic and solve easy subgoals with S-trivial. And we are left with one goal. Here in the antecedent of the implication, we have a Boolean statement. That is an argument to the isTrue coercion. X smaller or equal n, where smaller or equal is the computable Boolean function on natural numbers, and B, sorted B, and const L. sauto cannot directly work with such statements. It works with inductive types, so Boolean statements need to be reflected into propositions in prop before sauto can do anything useful with them. This Boolean reflection is achieved with the reflect tactic from the reflect module. sauto uses this tactic internally when the bref option is enabled. So let's see how breflect works here. We see that it converted this the comparison and B into corresponding propositions in prop. By default, breflect handles Boolean connectives like and B or B and so on, and Boolean comparisons from the standard library. It is also possible to add custom reflection principles for breflect. More about this later. Okay, so we performed Boolean reflection manually. Now the goal should be provable by sauto without the bref option. Let's try it. But it still doesn't work. Let's look closer at what's happening here. The problem is that by default, sauto eagerly eliminates all match discriminates by repeatedly applying case split followed by subst and simple. We call this heuristic eager case splitting. This is often a useful heuristic, so it's enabled by default. But for goals involving computable Boolean functions, it sometimes becomes counterproductive and prevents sauto from solving the goal. The tactic case splitting performs eager case splitting. We see that after reducing here with simple, we expose a match. So case splitting will distract L here, then reduce with simple, then find another match to distract, and so on and so on. And always after reduction here, we will expose another match where case splitting will then here eliminate the discriminant and then reduce and so on. So it will loop. So we see it loops. The eager case splitting heuristic may be turned off by disabling the e-cases option. When we do this, we see that sauto can solve the goal. So that was the problem. Setting e-cases off doesn't disable case splitting entirely. It is still performed non-eagerly with backtracking during proof search. One can specify precisely for which inductive types case splitting should be performed. Here we provide an empty list which disables case splitting entirely. Surprisingly, sauto with bref on also solves the goal. This is because setting bref on implies setting e-cases off. This is the most common combination. Some options also set other options to values most commonly used with that option. In such a case, there is always a primitive version of the option with a bank appended, which affects only the action of the option and without setting other options. For example, setting bref bank on enables Boolean reflection only without disabling eager case splitting or affecting any other options. Okay. So we repeat here the definition of insertion sort. We prove our helper lemma, this time formulated using the sorted B computable Boolean function instead of the sorted inductive predicate. Sauto can solve this goal like as before if we enable Boolean reflection. Again, it works a bit quicker when we provide the inf and ctrs options. Now we show insert preserves sortedness. Boolean reflection also needed here. Finally, we show that the result of insertion sort is sorted. We don't actually need Boolean reflection here. As I mentioned, a Boolean reflection in breflect and sauto can be customized. This is done by adding lemmas stating equivalence between a Boolean function and an inductive predicate as rewrite hints to the bref rewrite hint database. In fact, the breflect tactic is nothing more than generalized top-down rewriting with rewrite hints from the bref database. Here we add our lemma connecting sorted B to sorted to the bref database. Now the breflect tactic also converts sorted B to sorted once we have added this rewrite hit, as we see. And we can prove this lemma. If we try to prove the lemma with sauto with the bref option enabled, this won't work, because sorted B will now be converted by sauto to sorted, because sauto internally uses breflect. And then to solve the goal in reasonable time, sauto seems to need the eager case splitting heuristic, which setting bref on just turned off. So as we see, this doesn't work. Eager case splitting is usually a good idea for non-Boolean goals involving inductive types. We can use bref bank to enable Boolean reflection without disabling eager case splitting. And then this works. With bref bank, we can again prove that insert preserves sortedness. And finally, we prove once more that the result of insertion sort is a sorted list.